Welcome, ladies and gentlemen, to today's program. Today we shall look at length and volume. Now, ladies and gentlemen, we shall begin by defining what measurement is. Actually, measurement is defined as a process associating numbers with physical quantities and phenomena. Measurement particularly is important in engineering and science. Now, ladies and gentlemen, what are some of the basic physical quantities that we are going to deal with, or we are going to discuss under measurements? One of them is length. We also have time, mass, electric current, and thermodynamic temperature. Now, let's look at the SI units of measurements. Now, for measurement to be taken, there must be a standard unit. That's a unit that's agreed upon. It's a conventional unit which is used internationally. Though measurement units vary, or preferences of measurement units vary from country to country, but there are units that have conventionally been adopted. That when trade is done between countries, those units have to be, because they're understandable by or understood by everybody, they are to be used for as standard units of measurements. Though we have countries which have adopted their own units of measurements, which are different from those others, like the United States, use quite unique units of measurements. Like you'll find that they measure mass, weight in pounds, while elsewhere people concentrate on using kilogram for mass. That difference is actually vivid. So a set of metric units that are used or agreed upon internationally is what we refer to as SI units. So we want to relate the basic physical quantities to the SI units, beginning with the length. The SI unit for length is meter, or the meter. For mass, we have the kilogram. For temperature, the Kelvin. For time, second. Amount of substance, we have the mole. Now, we begin by defining length also, before we go into instruments for measuring length and also the calculations. Length has a number of definitions. One of the definitions is the distance traveled by light, and that's actually the current definition, the one that's currently being used. The distance traveled by light in a vacuum during a specific time interval. Of course, we know that light travels at a speed of 300 million meters every second. So length is actually defined in that respect. Other definitions we have measure of distance, or distance between 2 points or 2 marks on a certain metal bar. That was the previous definition. Then some of the instruments that are used to measure length, we have the ruler, we have a meter scale, we have a measuring tape, vernier caliper, and micrometer screw gauge or screw gauge. Screw gauge could differ. We have a micrometer screw gauge one, which measures very small quantities of length. Then we have multiples of the meter. 1 kilometer is equal to 1,000 meters. That would mean that 1 kilometer is equal to 1,000 by 100. That would be 100,000 centimeters, and so on. Conversion can continue on and on. Then we have 1 decameter. equaling to 10 meters, and then 1 hectometer equals to 100 meters. Submultiples of the meter, 1 decimeter equals to 10 power negative 1 meter, 1 centimeter equals to 10 power negative 2 meters, and so on and so on. So you go until you reach nanometer, where we have 1 meter is equal to 10 power 9 nanometers. We have 1 meter equal to 10 power 6 micrometer, and so on and so forth. So then we shall define a ruler, which is basically the most basic instrument for measuring length. You can see it has got that this one is in inches, but basically many schools or many institutions have them a ruler, 1 meter ruler, or the scale that has calibrations of a meter, but with the small divisions of a millimeter. So we may refer to such scale as a millimeter scale if, for example, one small division is a millimeter. Now, how do we use this millimeter scale or this meter ruler? Of course, this one here is indicated in inches. The eye must be placed vertically or directly above what you are reading, above the scale. You can see the position of the eye here. And that will eliminate an error which we refer to as parallax error. Now, parallax error is basically the movement of what you are reading based on your movement, the observer. So whenever you move your eye or use two eyes, you get to see a different reading depending on your position relative to what you're observing. Let's look at the physical quantities that are derived from length. One of them is area and volume. So we have area could be length times length, and volume could be length times width times breadth. So because length is the basic quantity, width is equally length. Actually, width is length, only that probably the dimensions are different. If we're not talking about a cube, then we are talking about a cuboid or any other shape. Whatever the case, length is a basic quantity. If multiplied by itself a number of times, then that result is a derived quantity from that particular basic quantity length. Then we have area, which we've just a minute, I take you back. Area is length times breadth. And the SI unit for area is the square meter. Of course, there are other units for measuring area. For example, we may use square centimeters, we may use square millimeters, but this SI unit value or unit, the SI unit that's conventionally agreeable is the square meter. Of course, the formula for determining the area depends on the body or the surface whose area is to be determined. If you look at those diagrams there, you'll be able to see like parallelogram, use base times height, and so on, for a circle pi r squared. Very elaborate. Then we have multiples and submultiples of the square meter. We can see that 1 square meter, okay, let me not go that way. We say 1 meter is equal to 100 centimeters. That means 1 square meter is equal to 100 by 100, which will give you 10,000 square centimeters. And you can go on and on and say 1 meter is equal to 100,000 millimeters. So 1 square meter is equal to 1,000 by 1,000. That will give you 1,000,000 square millimeters, and so on. We can say that that's a submultiple. For the multiple, we can talk of kilometer. Oh, that's quite big. It's quite big. Yeah, kilometer is equal to 1,000 meters, and a kilometer squared will be 1,000 by 1,000, which will be a million square meters. Very important to note indeed. That was a derived quantity area. Now the derived quantity volume, we begin by defining volume as the amount of space occupied by matter or body. The SI unit for volume is the cubic meter. Of course, we have other units for measuring volume, like cubic millimeters, cubic centimeters, and so on. And don't confuse it with capacity, which more or less would insinuate the same thing, like the liter, the milliliter, and so on. Of course, 1 cubic meter is 1,000 liters, to be noted, and so on. But this is volume, not capacity. Volume is the derived quantity of length. You can see length times length times length, or length times breadth times height, meaning the same thing, depending on the dimensions. For a cubic object, it could be length cubed. So the figures there show various formulas for determining the volumes, including that of a sphere, cylinder, cuboid, cube, and so on. Let's look at the volume of liquids. The most accurate instrument here for measuring volume would be, among the two indicated here, the burette, where you put water you fill it to 0 volume up there, then you let water come out by opening the tap, and you measure accurately that volume, how much liquid comes out. Or you can use a measuring cylinder. But in either cases, your eye must be placed at the bottom of the meniscus. So that means if you have something like this, if you have a cylinder like that, and that's the bottom of the meniscus, then your eye must be placed at the bottom of the meniscus. This is for water, of course. The meniscus curves that way. But if it were a different liquid, like mercury, then your eye must be placed at the top of the meniscus. So either way, you must put your eye at the correct point. Remember, we talked about parallax error. You must avoid errors when you are taking instruments. So, ladies and gentlemen, today I was just discussing volume. This is our first session in this channel. And volume and length have been well discussed. We look forward to discussing more and more, including advanced contents. This one I just started with simple content to introduce our young viewers in junior schools and so on. But high school viewers, advanced levels, will also be taken care of. Otherwise, ladies and gentlemen, I'm so grateful for your watching. Please keep coming back to watch, subscribe to my channel, and like the video. Thank you very much. I am Tutor Martin.